So guys, today I'm going to present my real estate analysis on the data analysis on the real estate market. So what's the problem statement? So the problem statement exactly is like the real estate investment sector, particularly the multifamily property investment faces numerous issues. Like they have the challenges in making the decision making information using the data and like what's the investment process. So we don't have any particular proper made pipeline for that. So what's the scenario behind this? Like there is no proper data available with the people, due to which we are able to make an informed decisions. Like the investors are making the decisions based on the market trends and analysis, and they might end up buying the properties in the area which might not be that worth of investing. So just to be sure, like the if any particular people is investing in the properties, is having the informed decision in which area he should invest so that he can get the maximum returns through the investment. So like what is the approach to the problem what I have taken? So as the data we required wasn't easily available, like it's available on the different websites and sources, but the data we required was in the CSV format, like, or the text format, which wasn't quite readily available through. So for that we made need to get you make use of the web scrapers or the APIs. But the main problem what we faced with the APIs is like the we weren't able to get the APIs access, because they required us to have the proper MLS listings, or we need to be an MLS agent so that we can access the database. So we were left with only one of the options, which was to web scrape the data. So web scraping is a method in which we are going to make the calls to the servers, and we are going to collect the data, and we are going to store it locally. So in the current project, what I'm doing is making use of the home harvest. So that's basically an Python library which is making use of the realtor.com for web scraping the data. So we are getting the data which we required via the home harvest, and I'm storing that in the form of an CSV. So next is like the steps which are involved is like we do have the cleaning and the pre-processing of the data, so that we make sure like there are no unwanted columns which we like there are no columns which are unwanted in the data which is not required for the analysis, or like which won't be making any much impact even if we don't have the columns in our database. So the another step is like we need to go for the visualization before doing any analysis, because that is the key for that is a key due to which we are going to make an informed decision, because as it's having the more information, it will be the visuals will be providing more insights how the data is being processed, or like what kind of data is there and what's the skewness and the behavior of the data. And based on the analysis and the visualizations what we conclude, we are going to apply the machine learning models. So let's deep dive into the project. So over here, what I have made use of is the basic Python libraries which are required for the machine learning, in which I'm making calls to the NumPy, Pandas, Matplotlib, Seaborn, SNS, Plotly, and the scikit-learn libraries for pre-processing model selection, linear models, matrices, and basically I'm also making use of the home harvest, which is basically for scraping the property data. So over here is like I'm fetching out the data. So home harvest is having the four options to fetch the data in the listing types. We can have pending, we can have the apartments which are already on sale, which are available on rent, and the final, the ones which are already sold. So over here is like what I'm doing is I'm uh, scraping the data for each and every department listing type. So the ones with pending, the another one is for the rent. Here is the data for like the web scraping for the sales, and the final one in which the properties which are already sold. So what I am doing is like I'm just saving that in the current directory, which is my user data. I'm just making use of the user data to store all my data. And on this, what I'm doing is I'm merging each and every, like whatever the uh, CSV files we are going to have. Like we don't need to manually encode it. Like we don't need to have hard coded methods to select all the CSVs. We just need to pass the folders, and it is going to select all the CSVs in that folder, and it's going to create a data frame which will be having all the data from the sales, pending, then it is also going to have the sold as well as the rental data. So now this is like the basic information, what kind of the data it's like, what's the object type of the data, is it like what's the data type of the data, like if it's like the property URL or the MLS ID status, which are like kind of alphanumeric. They are basically the object data type, and the zip codes, the beds, full baths, half baths, etc., which are basically, we normally have the concept of 2 bed 1 bath or 2 bed 1.5 bath. So basically on the point of that, it's just having as a float data type. Now, this is just describing the data, or like what's the count of the data, mean, standard deviation, minimum, the 25th percentile, the 50th percentile, 75th percentile, and the max. So over here we can see like there is a discrepancies over like in the counts of the different columns. So that's basically because the owner or the listing agent hasn't provided the all the informations available on the websites. So basically to figure that out, we can't accommodate the changes. So over here when we check like for the null data, so we check over here like the property URL, it's not null, the MLS is not null. Like they don't have any null values in that. But when we see the text, they do have the null values present. The unit, because like if there are many apartments which can be kind of a single unit, or there might be apartments, like there are many apartments which are having multi units in the same apartment. So that's the reason we do have the uh, missing values in that. Over here also the beds, so basically the people haven't, like the agent who hasn't provided the complete info on the number of beds, the baths, and the half baths if it's there, and the area. So because of which we can't make an informed decisions. So now what we are doing is we are just going to drop the columns like the property URL, MLS ID, text, photos, broker phone number, latitude and longitude, because that are redundant data and it's like we don't require that. So this is the final data frame in which we are going to have all the data. So now again, we are just making sure like whichever columns which are dropped over here, it doesn't shows up again. Now like if we are going to do the null value calculation, it's going to be there. So after doing that, what we are doing is like we are just dropping out the duplicates so that we don't have any duplicates in our data set. So basically there is a drawback in this if we are using the duplicates, because like there might be like these full street line, like they might have a different unit. So for this, what I did is for the duplication is I combined the street and the unit so that we can get the unique values. So from that I'm making dropping out the duplicate, so we can't have the MLS IDs or like any of the other keys as the unique key. So because of which I created a full street line, so like which is a combined address for the street and the unit. Now if I'm checking again for any duplications, it's coming out there are no duplicates. So as our data is like in different data types, it's having the float and the object. So what over here I'm going to do is like I'm going to label and code the data so that it's easier for us to like have a proper data set in which we can just have the values which are in the integer format. So what label encoding does is like label encoding will be labeling the data. If it's 07306, it's going to label that as 1. 07307, it's going to label that as 2. So it's just going to label that, and wherever it's 07306 or 07307 are present, for example, it will replace the each and every iterations as 1 and 2 respectively. So this can be done for the object data types as well. Now over here like we are as we has like label transform the data, so it's just transforming the data and we are just making sure like we are just having the integer data type present over here, and we don't have the object data types. So now what we are doing is like we are just appending the columns over here. So as we can see, like all the data types has been changed from the object or float to the integer format. So which is easier for us to do calculations. So based on this, like what we over here have, like what I have over here have is the correlation heat map. So like what's the correlation between like the style and the street, like what are the people looking for. So basically it's a kind of a heat map in the range of -1.1 to -0.9. So it's going to predict like whatever the correlations are going to be there. But over here kind of we do have a drawbacks, like which is showing like all the correlation heat maps are coming out to be of the same input. So like that's basically we are, because of the skewness of the data, because we have just label encoded the data. If we are able to get the data in the proper format, like without the use of the encoding, so that will be of much more help. Now over here, like what I'm doing is I'm just making use of the Python libraries for the visualizations, and which I'm making use of the styles and the skewness to figure out like what is the skew of the data in the form of the bar plot and the like the histogram. So this is this thing. This is the like the data which we have over here. So like based on this, we do see like there are many people who are looking for like the HOA fees should be less, or in the park they should have the parking garage, or like that's basically the county which they are looking for. So that will be having a different impact. So for each and every county we need to have a different analysis. That one model might be good for one county and not for the another one. So basically for this we are just focusing on the Jersey City, because like that's the area we know which has more amount of the students, so and so that can help us the investor to make an informed decision. So over here, it's like just I'm doing a swam plot between the style and the street. So we can see like there is, like the streets are basically label encoded, so we can't exactly figure it out which streets are label encoded on the which one. So that's a basic drawbacks of the label encoding. Like we can't map the data so much efficiently. Now applying the machine learning algorithms. So over here I'm just splitting the data in the 80/20 format. So 80 is the training data and the 20 is the testing data. So this is my data column for the X test, X train, Y test, Y train. Now I'm making use of the random forest classifier because this is an unsupervised data. Like we don't have any kind what supervision on the data, so we are making use of the random forest in which we are going to predict the matrices based on the accuracy score, precision, recall, and the f1 score. So over here is like the random forest. So we are having the estimator forest is like the 100. So we are going to go not go much. It can have the, we are not providing any depth for the forest. It can go on and on because it's like it can have the max that as the default values. So over here, when we go and predict out according to the classification report, we get an accuracy like of 99% on the training data sets, and that's the same thing for the precision, recall, and the F score. So applying the k nearest neighbor, because that's also an unsupervised machine learning algorithm. So over here, what I can do is like, oh, I'm getting the accuracy of the 96 percentage, but over here, like basically what I can say is as the data skewness, because like we are not having, because the data type which we are collecting and the data type which requires a machine learning algorithm to be analyzed, it's in the different format. So because of which we are getting an accuracy which is like very, it's like too good to be true. So based on this, like we need to like focus on the data in which we can apply the NLP, like which are like more on the automation process via NLP, so that we can also include the people's sentiment. So so including the people sentiment. We can also include the neighborhoods. We can include the text format. But due to the computing power, I wasn't able to do that much on my system. So that's it. That's the end of my project. Thank you.